This is about rotating conics from section 9.4, and we're going to use this equation to help us determine the first few things that we need to do. It has an xy term, and that's what tells you that it's a conic that's going to be, instead of along the x-axis or parallel to it, or parallel to the y-axis, it's going to be tilted, some percentage. And if you've already gone through this in the textbook, you have an understanding of what they look like. Well, the thing that we have to do first, in order to both determine, well, you can determine which conic it is in other ways too, but we're going to determine the equation of the conic to help us with the graphing of it, but we have to eliminate this xy term and write this in a different form. To do that, we're going to be using x prime and y prime. So what we have to do is change around this, and we have to do this where the x is going to be equal to x prime, the cosine of theta, which is the angle of rotation of the conic, minus y prime sine of the angle, and the y value is equal to x prime sine theta plus y prime cosine theta. So these are similar but not exactly the same. But it does make sense that for the x value, cosine comes first before sine, because, like on the unit circle, the cosine is the x value, and the sine is the y value. So for the y, sine comes first, then cosine. So cosine, then sine. For the y value, sine, then cosine. And the y is positive and the x is negative. You would have to memorize that there. So you need to remember those little formulas to determine the x value and y value. Right now, I'm going to give you that the angle of rotation is 60 degrees. Sometimes you'll be given it, sometimes you'll have to determine it. And the next lesson, after going through the first steps with this one to graph this, is to, it will be to determine that from the coefficients here, the a, b, and c. So what we're going to do now is use 60 degrees as these angles. So the x value, x equals x prime cosine 60 degrees minus y prime sine 60 degrees. And I'm going to do the y here. Y is equal to x prime sine 60 degrees plus y prime cosine 60 degrees. Okay, now, from the unit circle, we can determine what those are. X is equal to x prime, so the cosine at 60 degrees is 1/2, and the sine at 60 degrees is the square root of 3 over 2. For the y value, that's reversed, because the sine of 60 here, the square root of 3 of 2 over 2, will go first with the x prime. Square root of 3 over 2 plus y prime 1/2. And those, of course, come from the unit circle. Another good reason why you want to know it, and if you do know it, you can write it out for yourself if it's not given to you. And so at 60 degrees, or pi over 3, 1/2 for the x, and square root of 3 over 2 for the y, or cosine and sine. So that's the cosine, that's the sine at 60 degrees. Okay, now we can go a little further with it and simplify it. So it's 1/2 x prime minus square root of 3 over 2 prime. They both have the same denominator. So one way to write this is x prime minus square root of 3y prime over 2. And that's what we'll use for this, because the textbook uses it. I actually prefer it the other way here. But I'm going to follow through with what the textbook's doing right now. And then at some point you can turn these into decimals and do it that way instead if you prefer that. And we'll go over that later in this lesson as well. Okay, y is equal to square root of 3x prime plus y prime over 2. So now we have these two values. Now what we're going to do next is to put them into here in order to change that. And one of the keys you're going to find out is that if you put this in and do all the calculations correctly, the xy terms will just disappear. It's purposely happens that way, that this is a way of getting them to be gone so that you can get an equation. I'm going to need to get the correct equation to use to rotate with. I'm going to need another piece of paper because this ends up being a good deal of work, and let me show you just what happens. 13x squared minus 6 root 3 xy plus 7y squared minus 16 is equal to 0. So we're going to take that x value and put it in for the two x's. And we're going to take that y value and put it in for the two y's. Just as if we put in a number and we had to calculate it, but we're going to do the same thing. It's just going to take a little more patience and doing it more carefully. So that's 13x prime minus square root of 3y prime over 2 squared minus 6 root 3 x prime minus 3 square root of 3 y prime over 2, and then the y value, square root of 3 x prime plus y prime over 2. So that one times each other, that x times that y, plus 7 times the y squared, square root of 3 x prime plus y prime over 2 squared equals 16. So I'm going to add 16 to both sides here. This one now, I can't just square that and square that. I have to actually do it out twice. So it's going to be x prime minus square root of 3 y prime over 2 times x prime minus square root of 3 y prime over 2. Here I can start multiplying. I can do, well, first, it's going to have to be in parentheses. I'll have to do this after in another step. This times this is the square root of 3 x prime squared. Oh, brother. I have to do that too. That times that. This times this, that's going to be plus and plus, so it's going to be plus x prime y prime. Okay, or is it minus? Oh, let's see, is that times that? Okay. Then it's going to be this one times this one, which is going to be, oh, brother, now we are getting into, let's see, minus square root of 3 times square root of 3 is 3. It looks like it's x prime y prime. And then this one times that will be minus square root of 3. Oh, no, that's y prime. Yeah, no, that's x prime, y prime. This one's y prime squared. Okay, and all of that over 4. 2 times 2 is 4. Plus, well, I'm going to have to come down here to do the next one. In a moment, we'll make this negative 2, x prime, y prime. And at this point, at some point, I just stop using prime until we get to the end. I mean, it's so much hassle writing that in all of them, and then with the square too, that I would just do it without it. I would do 7 square root of 3x plus y over 2 square root of 3x plus y over 2 equals 16. And then on the next step, I'd multiply these two out as well and do the coefficients and keep on going. And oh boy, it keeps going like a lot. Well, you know what? I'm going to tell you here, in fact, I need to show you the problem here that we're doing is the same one in the textbook that's number 14. And here is their worked out solution. So I'm stopping at about somewhere in this part here. And if I kept going, I would get things to work out. Well, they did a few things together. They squared this, and instead of showing the intermediary step, they just have it squared here now. They squared this, but they combined the like terms and here and this one. And then they multiplied both sides by 4, and that got rid of the 4 denominators and made it 64 here. And then they started putting things together. And that's where I want to show you and have you notice a couple of things here, is that these squared terms all would be combined. Where's the x squared terms first? Okay, those all add up to 16x squared. The y squareds, oh, same thing here. Okay, and those end up 64y squared. And negative 26 root 3 of the xy. and plus 12 and plus 14, well, that's plus 26, so it's minus 26, and day went away. So we get to this, and now it becomes a lot simpler. Divide both sides by 64, and you get a 4 on the bottom here and a 1 on the bottom here. Oh, much, much easier to work with, but you have to go through all of that first. Oh, boy. Oh, let's come back here. I'm going to put dot, dot, dot. And what we have now is x squared over 4 plus y squared over 1 is equal to 1, and it's prime. Yep, can't forget that prime. Now I'll put that back in here. But now we have something we can work with for graphing that's much easier, because we see here, since these are different numbers, this is an ellipse. If they were the same numbers, it would be a circle, because we would multiply, we'd have the radius here. But we have an ellipse, and we have a center of 0, 0. Okay. And we have an a of 2. That's a squared. This is b squared, so a b is 1. So we're going to set up and do a little beginning graph here. So what I'm going to do, I'm going to go out 1, I'm going to go out 2, I'm going to go out 1, I'm going to go out 2, 1, 2, 1, 2. Okay. Good enough for the purposes of what we're doing here. That's 1, that's 2. Now, I'm not going to graph this way fully. I'm going to put dotted lines, dotted little dots or dashes. I know the center is 0, 0, and the larger numbers under x, so we're parallel to the x-axis right now. So we'll go out to the 2's and up to the 1's, and so this is the approximate ellipse right now. However, we were told, or I told you back at the beginning of this, that we have a 60-degree angle of rotation. And you can estimate, or you can use a protractor, but you can estimate pretty well after doing enough of these things that if that's 90 degrees here, then 45 degrees is right in the middle. 60 will be at 2/3 of the way, so I'm going to guess here that this is about where the new axis is. So what's happening is that this is going up like this. The x-axis is going that way. And then the y-axis also has to do that. So, and I want to be like perpendicular to it, so I'm going to be about here, looks like 2. So that one's moving also. So what's happening is, having graphed this, the whole thing just moves that way, as if the 1 were to go here, the 2 were to go about here, and this 2 about here, and that 1 about here, and that 1 about here, which means now we could do our graph through those points. So that dotted dashed one has been translated, moved, rotated this way, the whole x-axis moved that way, 60 degrees up. We always move in that direction. And we're always moving, all of the ones you do are going to be moving less than 90 degrees. So we're always moving this way with each of them. And so, there we are, we did it. We got the equation without the xy term, and with prime, of course, because it's an equation for a rotated conics, and we graphed it here. Whew, there's a lot to that one, but it works. It works quite well, too. What we're going to do next is go on and figure out how to get this angle when you don't have when it's not given to you. And that's part 2 of this lesson coming next.